Good morning. It's great to be here at Web Summit. My job is literally to ask people questions, so to be stood up here on my own is a little bit of an unusual situation for me. I'm here today to talk about a crisis of our own making. AI is rightly the topic of so many different stages at this conference. It's accelerating opportunity faster than ever. And it's not a new technology. Look, we all know that it's been around for some time, from machine learning through to agentic AI, offering opportunities and capabilities that we've rarely seen. But it's colliding head-on with a physical force, power. When we talk about AI, we tend to focus on the economic opportunity. We think about its impact on the talent industry. We think about the ethical considerations. But today, I'm going to talk to you about the invisible price of that progress. Because every prompt we type, every token we generate, every model we train, it costs real, finite power. But it's more than just a climate issue that I'm here to talk to you about. It's a scalability issue. If we don't solve the power problem, all of the opportunities that AI presents to us across healthcare and education and our society at large won't be realized. I work for a global recruitment firm called Harvey Nash and have done for 18 years as our group technology evangelist. And for the last 10 years and some 900 episodes, I've published a podcast called Tech Talks. That gives me the opportunity to talk to a lot of the leaders across the industry. And one topic that has kept popping up again and again is this cost of progress. So naturally, I wanted to explore it in a bit more detail. Earlier this year, we made a documentary exploring it, where I went and spoke to policymakers, educators, leaders across the space to try and work out how we tackle this issue. And I'm going to start today's talk by showing you the first 5 minutes of that film before we dive into it in a little bit more detail.
Las Vegas, Sin City, a playground in the desert that occupies a place in our collective imaginations for glamour and excess. Sphere is the latest representation of that. It's a mecca for entertainment, at the bleeding edge. But there's a price to pay. It costs about the same amount of electricity that you would need to power 21,000 homes to keep the lights on. And they're building a $1.4 billion solar park on the border of California just to do that. In many ways, it reflects the technology industry as a whole. We're striving for exciting breakthroughs in healthcare, in education, even in trying to tackle the climate crisis. But the price is high. It would need us to reforest a country about the size of Germany with 40 billion trees just to offset the carbon that we're burning through when we sit in our living rooms, streaming, searching, and prompting. Our own research suggests an abdication of responsibility. Less than half of those sitting around boardroom tables recognize the crucial role that technology can play in tackling the climate crisis. Most companies don't even have a net zero target. You're left with the overwhelming feeling that the technology industry is hoping that someone else is going to pick up the bar tab.
This week, over 130,000 people will be in Vegas for the Consumer Electronics Show. And the CTA, the company who runs CES, have placed sustainability and the energy transition at the heart of their annual conference. But where is the line where tech stops being part of the solution and this all spirals out of control? To help us understand the issues, we first need to leave Las Vegas. Our investigation has to start with data because data is everywhere. Without it, many of the services we rely on day to day grind to a halt, and the innovations at CES just wouldn't be possible. So to better understand the impact of data, I've come to Windsor to talk to NetApp, who describe themselves as the intelligent data infrastructure company.
The global data sphere, so kind of every piece of data created by everything The projections are it'll be about 175 zettabytes when we get to 2025.
I don't know what a zettabyte is.
So the next one's going to be even worse then, because that puts us on a path to hit the yottabyte problem as we get out towards 2030. A yottabyte is 1 trillion terabytes. That's the equivalent of every single human being on the planet carrying about 300 iPhones.
Everything that we use, getting here today, Google Maps, etc., is reliant on data. There is this flood of data being created, and it is only increasing. That has to place huge stress on critical infrastructure, and that also has to have stress on the environment.
21% of Ireland's electricity is currently going to data centers. At the moment, about 20% of that power is related to storage. Now, that's forecast that it could hit 38% or more by that 2030 timeframe that we mentioned earlier on. But here's the killer statistic. 68% of the data that we store is fundamentally a landfill of garbage that we do absolutely nothing with after it's been created. It is what we call single-use data. The amount of power or the amount of emissions that are created by the single-use data is typically more than the emissions that are created by the entire airline industry.
What does that really look like in terms of the demand on infrastructure and the demand on energy?
Because it's so invisible, it's hard for people to comprehend just what the scale of the impact is. You can see a plane, you can see a car, you can see those things. You can automatically start to get a feel for the emissions that are coming from it. Whereas if you look at Ohio, it's 50 data center providers looking to build 90 new data centers. They estimated that the amount of power at peak load, because these are data centers for AI and they have a much higher level of power requirements, the estimated level of power was that would be the equivalent of 21 million households. That is just 90 data centers in Ohio. There are currently 11,500 data centers in the US. And to meet the AI ambitions, is it double? Is it? I don't know. But data centers that we're building for AI are very different than the data centers we built for cloud. Cloud data centers, we're talking about 10, 15, 20 kilowatts per rack. AI data centers, 150 kilowatts plus per rack.
Industry is highly competitive, and AI is making it easier to identify and tempt you.
Well, I think the mechanism to deal with the problem you identified is through what's rather grandly called industrial strategy.
Anytime I raise environmental issues with our volunteers and our leaders, that's the number one issue they want to talk about and do things about.
In 2006, the mathematician Clive Humby coined the phrase, "Data is the new oil." And 20 years on, frankly, it feels as fresh and as relevant as it ever did.
So let's recap the scale of the problem here. Data centers built for AI are vastly more power hungry than those built for traditional cloud services. They need far more power per rack, and it's placing huge stress on the existing grid. Matt there talks about some really scary statistics. 68% of the data we create will never be used again. It is garbage, creating more emissions than the entire airline industry put together. I think the problem is because that data is invisible, because we can't see it smoking, we forget that it burns. And it seems a little bit basic to ask why this matters, but it matters because we're doing such a poor job of articulating the arguments around it. When we talk about sustainability, I often feel like there's a shock and awe element of tactics going on. Those who truly believe try to convince those who are more skeptical by throwing big numbers at them. It's a criticism, but I think it's a fair criticism because we see it happen again and again in these talks. Here's an example of what I mean. Data centers will use 580 terawatt hours of power by 2028, give or take 12% of the US's entire electricity. It's the kind of statement that should scare people, but for whatever reason, the argument doesn't cut through. Harvey Nash have published a report for over 25 years called the Digital Leadership Report. In that, 2,000 leaders contribute every single year, and they report that just 44% of boards support net zero targets to a great or extreme extent. Half remain disengaged. So you have to ask the question, where we're going wrong. Well, today I want to talk about three core things: scalability, performance measurement, and the failing commercial argument. So what do I mean by scalability? As we said, power is a scarce resource. There's a huge growth in the level of data needed to fuel AI, and it's far more dense, which, as you guessed, means more power. And if the problem isn't solved, we can't scale, because we won't be able to access the level of compute that we need. It's a huge problem because we're not talking necessarily about the success of one individual company here. We're talking about whole national growth strategies. In the UK, AI growth zones are a central pillar of the government's strategy to address the massive power concerns needed. The AI growth zones, in theory at least, help grow that staggering amount of AI in hand with clean energy solutions for regional parts of the country that have been left behind. I interviewed the Secretary of State here in the UK, and we talked about communities like the one I grew up in, ex-coal mining communities that have been left behind. But crucially, where we have legacy infrastructure that can be used to meet this surge in demand. The opportunity to create social change and investment is huge. But without carefully considered planning and by simply expanding that data center capacity, we risk not taking advantage of what we already have in place. On the podcast Tech Talks, I talked to Arm's Chief Commercial Officer. Will talked about a situation in Scotland where data center rollouts were put at risk because the existing grid couldn't cope. The example he gave me was that they were faced with the dilemma of turning off the lights in a data center or turning off the lights in a local school. It perfectly describes what we're on about here, and we're crying out for leadership. So I think it's great news that in the UK, the government's established an AI Energy Council bringing together various different players from across tech and industry. We're talking about companies like Google, AWS, and Microsoft to co-chair discussions on powering AI efficiently. And of course, there's also room within tech itself to innovate. Will talked about Arm redesigning their stack, considering how they can create solutions to their own challenges. And in the film, I speak to a company called Literal Labs. They're a UK-based startup who have a radically different approach. They're thinking about logic-based, not neural network-based approach to AI that can deliver the same results 54 times faster, but using 52 times less the amount of energy. It highlights the need to shift from maximizing performance, which we see go hand in hand with complex AI systems, to minimizing resource consumption through innovation. We also talk about performative solutions. Well, what do we mean? On the podcast, I interviewed a guy called Raphael Guller. He's the co-founder of Sweep. Sweep are an enterprise sustainability data management platform. And he told me about an airline company that were tackling sustainability by replacing the plastic cups in their office. 99% of their carbon footprint comes from planes, funnily enough, and fuel, which makes changing the plastic cups in their office look faintly ridiculous. It's greenwashing. In our film, NetApp say their customers are hooked on cheap storage, and it shows that we need to show greater responsibility when it comes to actually addressing the consequences of the choices that we make. It reminds me, when I was in Las Vegas, of the signs you see in hotel rooms telling you to switch off your bedroom light and do your bit, when you go outside and you see the strip pumping light and electricity into the air 24/7. We need to actually identify actions that can move the needle. In the documentary, we talked to Slalom Consulting, who talk about their work on vanishing emails. They've got a project where they detect and delete commercial and promotional emails. We're talking about the kind that clog up your spam box and you forget about forevermore. Well, that project deleted 600 billion emails in just 1 year, and that reduced the level of data and therefore the carbon emissions in a year by 6,500 tons of CO2. It highlights what can be done when you lead by action rather than necessarily thinking about the optics or a tick-the-box exercise. Something else that comes up in our film is the relatively short tenure of digital leaders. Most net zero targets are on a much slower time scale than that. because they're only going to be in their job for 3 years. And the focus is so squarely on productivity and efficiency gains, is it any wonder that we see a lack of support for sustainability around the boardroom table? And the commercial argument is also absolutely key. I think our reflex is to try and win the green argument on ethics and on values. But Sir Vince Cable, the former UK Business Secretary, warned me that we cannot let ideology cloud our thinking. He stressed the need to focus on engineering and business goals, working with companies like he does in Texas. It's got the image of a kind of a drill baby drill state, but in Texas you find real green innovation around freight or haulage batteries for EVs. It's something that we hear again and again in the podcast. I interviewed a guy called Cyrus Vantock Wood. He's the real life Don Draper. He was an ad man who had a corner office overlooking Madison Avenue. Well, now he's leading a business which is focused on empowering sustainable, regenerative businesses. He recognized that change wasn't going to come from government or policy or charity. It was going to come from working with those businesses that he characterized as the worst, make money whilst doing good. And look, we can talk about the fact that that excess can save us billions of dollars, but some people also focus on the fact that quantum might be a silver bullet. They talk about the 2030s being a quantum decade. It's a technology that could provide some answers, but I think the problem is we can't afford to simply hope that innovation can solve the problems we're compounding today. That's luck, and it's criminal. If the last decade or so has been about moving fast and breaking things, I think now has to be about building smart and fixing them. The invisible cost of progress is only invisible until the power grid fails, the lights go off in the school, or the planet is damaged beyond repair. Pandora's box is fully open on this. As I said, I'm a technology evangelist. I love technology. If we have to sacrifice, or we have to make cuts to our lives, technology obviously greatly improves them, well, we're going to become frustrated. So we need solutions. But you can only fully embrace change and progress if this hidden price is actually addressed. I think what we need to do as an industry, what you need to do is think about energy efficiency in your designs. You need to think and demand for accountability across your policies. And you need to embrace collaborative solutions across industry. Only in that way can we look at the progress of AI and embrace it in a way that's sustainable, inclusive, and scalable for everyone involved. Thank you very much for listening. Enjoy the rest of your conference.